Bobby remembers his 7th birthday. The crooked cake. The blue balloon stuck on the ceiling. The tiny scar he got while running to open a present. There is only one problem. According to one of the strangest problems in physics, none of it had to happen. Bobby may have appeared in this room 5 seconds ago with every memory already inside his head. And so might you. You remember clicking this video. You remember what you did this morning. But if those memories arrived with you, how would you know? Before we finish, Bobby will try the one test that should prove he has a real past. What happens instead is the reason some physicists use this nightmare to reject entire models of the universe. To understand it, forget space for a moment. Imagine Bobby drops a neat stack of cards. They scatter across the floor. Nothing strange there. Now run the moment backward. Every card jumps from the floor, flips through the air, and lands in perfect order inside Bobby's hand. Physics does not clearly forbid every tiny motion. It is simply so unlikely that you would never expect to see it. This is the basic idea behind entropy. There are very few ways for a room to be perfectly arranged, and an enormous number of ways for it to be messy. Random motion usually carries things toward the kind of state that has more possible arrangements. Ice melts. Smoke spreads. A broken cup does not rebuild itself. Time seems to point in one direction because the more mixed-up states are overwhelmingly easier to reach. But overwhelmingly likely is not the same as guaranteed. In a small system, particles can briefly move into a less likely pattern. The larger and more organized the pattern, the less likely the jump becomes. A few particles might gather in one corner. 1 trillion particles arranging themselves into a working clock would be far less likely. An entire universe appearing in a neat, low-entropy state would be harder still. Now give empty space an absurd amount of time. If a rare event is truly possible, waiting long enough can make the impossible-looking event happen somewhere. This leads to a dangerous shortcut. Why wait for a whole universe like ours to appear? A much smaller accident could produce one observer for one moment. Particles could randomly form a brain. Not a baby brain with a life ahead of it. A finished brain containing the exact pattern that feels like your memories, your personality, and this room. That object is called a Boltzmann brain. It may float alone in darkness, it may last less than a second. Yet during that second, it could feel certain that it has been alive for years. Its memory of childhood would not be a faded recording of real events. The memory would be part of the random arrangement. The birthday, the scar, and the person it misses would all feel real even though none of them ever existed. This is where the idea turns toward you. A fake memory does not arrive wearing a warning label. From the inside, a brain that only remembers seeing a tree may feel exactly like a brain that actually saw one. Even the first minute of this video could be false. The universe would not need to create the earlier pictures, the computer, or the person who made them. It would only need to create your present experience of remembering them. That sounds like a silly trick, but it creates a serious test for cosmology. Some models say the far future settles into a nearly empty state and remains there for an unbelievably long time. In certain versions of those models, tiny random events never completely stop. Given enough space and time, ordinary observers like us may be greatly outnumbered by short-lived observers that appear through chance. And if a theory predicts that almost every observer with your exact experience is a Boltzmann brain, then the theory is also predicting that you are probably one of them. Notice what this does not mean. Physics has not discovered lonely brains floating beyond the stars. No telescope has photographed one. The Boltzmann brain is a warning created by following certain assumptions to their disturbing end. It is like a smoke alarm for theories. If your model produces far more fake observers than ordinary ones, something in the model may be wrong, incomplete, or being counted in the wrong way. Bobby still wants proof. He opens an old photo album. There is the birthday cake, there is the blue balloon, there is the moment before he got the scar. But the photos do not rescue him. A random brain could contain the experience of looking at random photos. It could even contain the memory of checking them yesterday. So Bobby asks another person. They remember the party too, but a single brain can produce the experience of a conversation. Dreams already show how a mind can surprise itself with words spoken by a person who is not really in the room. Then Bobby measures the world. He drops a ball, checks a clock, and records the result. Every test agrees with the last one. Still, the whole chain of agreement could be part of one instant of false memory. This trap is deeper than a normal illusion. If Bobby is a Boltzmann brain, he cannot trust the thoughts that led him to believe he is a Boltzmann brain. Physicist Sean Carroll calls this kind of theory cognitively unstable. The theory uses evidence and reasoning to convince you that your evidence and reasoning are probably random. It pulls away the ladder it used to reach you. That does not make the idea logically impossible. It makes the theory impossible to believe with good reason. If your conclusion says your own thinking is unreliable, the conclusion cannot proudly use that same thinking as proof. There may also be physical escape routes. Some researchers argue that a perfectly quiet vacuum does not keep producing real events just because we can write down possible-looking states. Other models let the vacuum change or end before enough time passes to create huge numbers of random observers. The answer depends on deep questions about quantum theory, gravity, and what counts as a real fluctuation. So the nightmare is not settled fact. It is a stress test. A healthy model of the universe should explain why normal observers with a real history are more common than momentary minds with fake ones. Our world does have one powerful clue. Records agree with one another. Tree rings, fossils, starlight, scars, photographs, and other people all point toward a shared past. That agreement is exactly what we expect if the universe began in an unusually ordered state and has been changing for billions of years. One long history explains many clues at once. A random brain can copy all those clues inside one experience, but it explains them by calling every agreement an accident. It can imitate evidence without giving us a reason to trust evidence. Science cannot give Bobby perfect certainty. It gives him the model that keeps surviving correction. The world pushes back, repeats itself, and lets other minds check the same result. That is enough to live by, but not enough to close the final door. Bobby can never prove with absolute certainty that he existed before this sentence began. So here's the question for you. If every memory could be fake, which would you trust most, your senses, other people, or the way the world stays consistent? Pick one in the comments and say why. Bobby chooses consistency. He places the birthday photo on the table and watches the clock move forward. For a moment, everything fits. Then the edge of the room breaks into drifting particles. The cake, the scar, the clock, and the orange scarf become one cloud of random points. Maybe Bobby has lived an entire life. Maybe he appeared when this video began. Or maybe the universe is not creating Bobby at all. Maybe, for one impossible second, Bobby is the universe remembering itself.